How many of you use Doctrine? Raise your hands. Keep the hands. How many of you loves Doctrine? And keep the hands, keep the hands. How many of you also hates Doctrine? That's the thing. And that's exactly why the title of this talk is Demystifying Caching Doctrine. Doctrine sometimes can be a beast, right? Because it is sometimes really hard to understand how to use it in the correct way, and therefore we get lost. But before getting to details there, let's understand why we use Doctrine ORM or any kind of ORM. There's a particular use case for this kind of library. The use case is enterprise software. Enterprise software is complex. It changes all the time. And when we create this kind of software, we really need to pursue three essential things: reliability, maintainability, and scalability. Reliability is the ability to behave correctly, so it produces the correct results, and no one can see any kind of issue or perceive any kind of issue, even though everything is burning on the like on the background, right? So if the software is facing adversities, as in hardware or software faults, or even human mistakes, for the end user, everything must be shiny and clean, right? Maintainability is about being able to work productively over time. I don't know how many of you were in the talk about code reviews, but there was a nice graph comparing when people were doing code reviews and therefore maintaining a nice and clean code, and when there was a mess. So over time, everything is so fast and easy on the beginning of the project. But when you go more and more like working and adding new features, it gets complicated if you don't take very good care about maintainability. And a scalable system is is one that can increase or is able to handle an increase of traffic Yes, and we're back. So I was saying that a scalable system, if we start receiving more and more requests, or if the payload of the requests start to increase, the system should also behave like everything is fine. No one perceives any issue. When you're developing this kind of system or software, you usually do some trade-offs. For example, in order to achieve maintainability, you decide to use some abstraction layers because, well, things like the Doctrine ORM, which abstracts how you interact with databases. But sometimes those abstractions will impact or have an impact on the scalability, because well, you need to do you have so many things happening at the same time to handle one request that your server is not able to process an increase on the traffic. So you need to create instances of your software like from nothing and just make everything running. And although we have no idea, when I say we, usually this is product people or sales people, we don't have any idea about the load parameters of our software. So we have no clue how many requests we need to be able to handle. What's the concurrency about that? But they just say, hey, we need to be able to handle 1 million of concurrent users. I'm 1 million of concurrent users. Like, do you have a clue about what is that? It's not 1 million of requests per day. It's like at the very same time you're receiving 1 million of requests. You need a very peculiar infrastructure, and your software must be really good to achieve that. My name is Luis Cobucci. I'm from Brazil, but now I'm living in Amsterdam. I work for Usabilla, where we analyze and collect. So we collect first. We collect and analyze feedback from customers. So if someone needs to tell, hey, company A, you're doing a very good job, or you're not doing a very good job, we allow the customer to talk to the company. And as any other company in the world, we're also hiring. So if you're interested, just look at there. For your information, we have Italians there already. So pineapple is not allowed on pizza already. So you don't need to worry. The baseline is set. But in the meantime, when I'm bored, I work on many different open source projects, and one of them is Doctrine. But what exactly is Doctrine ORM? As I said before, it is an abstraction layer to allow you to model and work with objects. So we're talking strictly about object-oriented programming, and you're gonna persist everything in relational databases. So for example, we have a software that sends spam or does something more sophisticated than just spam. It's a real email marketing software. And a very simple representation of this software is here, where we have a reusable template that can be used as base for many different campaigns. And we have a list of customers that will receive our messages that essentially are a connection. The message is a connection between the campaign and the customer. So based on this representation, it seems fairly simple. We have some relations. We have the multiplicity of the association, so you know that one consumer can be related to many different messages. The same goes to campaign. And this tells us that we have some interesting things. Template is a dependency for a campaign, and a customer is a dependency of the message. But also, the campaign is also a dependency for the message. This means that when you're storing and persisting your objects, the order is really important, right? So when you're doing this talking to the database directly, you're gonna have some insert queries to add the data. So first you have to insert the consumer. You put the ID of the consumer into a variable so that you can reuse afterwards. Then you insert the template, then the campaign, and finally the message. But hey, don't forget to use a transaction to wrap everything there. Otherwise, if this fails, you still have the customer and a template there. With Doctrine, we have this thing called Entity Manager, which is a way to interact with your entities. The Entity Manager, like this is the very basic interface of it. It has many more complicated methods there, but an example of use is this. We create the instances, we persist them, and finally we flush. And what this is doing behind the scenes is knowing the order of, based on something, the mapping of these classes, it is saying, hey, these are things or concepts that must be inserted before of doing anything else. So Doctrine, using all the things that it has to work, it will handle that for you. And there's a pattern that is called unit of work, which is really common for databases or for any kind of operation where you have to manage the state of multiple things, and after you have done all your work, you commit your unit of work. So when you're saying Entity Manager persist, you're adding to the unit of work. The data is, your objects are stored there, the references to them. And when you say Entity Manager flush, the Entity Manager says, hey, unit of work, commit. That will trigger the inserts to the database. When you already have something stored in a database, you can just do this, where you get a customer, get a campaign, and just create a new message for that, because you already persisted that. This is quite amazing, right? So you don't have many things to worry about. But one thing that many people complain about is ORMs are slow. And this topic is covered on many different talks, and it would take me a long time to just go through like in depth. But essentially we have three main reasons, or three problems in applications that makes you perceive ORMs as something slow. I'm not saying that they are not slow, though. First thing that you can improve and realize and see in your day-to-day application, and the problem is the famous the big ball of mud. The big ball of mud is when you have many components in your software, and they are all pointing to or related in a way to them, so you see this very weird graph that in a way seems like a ball. So this is very dangerous. Regardless if you're using an ORM or not, your application has a problem there. Second thing is about hydration. Hydration is an operation that ORMs do to translate the result set into a set of objects. So if you're just getting data from a single table, you do like select everything from a customer. That's fairly simple. You will have each row representing an object, so that's easy to hydrate. However, when you do joins, let's say that you have to get all users and all the messages. So the data set you have for each user, you will have like things duplicated for each message that you send to that particular user. To hydrate that into objects, things are very complicated, because you have, especially if you're linking the user, so you have in the user object a list of messages that you've sent there. So for each user you have to create a collection which will have the messages, and then this is something that every ORM struggles to handle. And the last thing is outdated things, which I mean by outdated software running in this operational system, outdated PHP version, and finally, outdated libraries. If you're using Doctrine, and everything that I will say here considers that we're running the latest stable version of Doctrine, which is the 2.6.1. This requires PHP 7.1 at least. So I expect you to update your cluster if you're not running that specific thing. All right, so now we understood some of how Doctrine works. We understood some problems that all the ORMs face. Let's try to make it fast. Making Doctrine fast is quite easy, but we have to understand, essentially we just use different caching layers. But what exactly is cache? This is the definition from Wikipedia, but in summary, the idea is to store a result of any kind of operation so that it can be served faster in the next request. So that when you're requesting again, you're avoiding the execution of that operation. Let's give you an example. We have this component, so our software, an external API that we integrate with, and the cache layer. When we're using cache, and this is usually the cache is integrated here because the external API takes too long to respond, or it has rate limits, so you cannot just every time send data there. So before of hitting the external API, we just say to the cache layer, hey, give me this particular key. And this concept now is just external.result. This concept is really important because usually caching, the caching servers or any implementation that deals with cache is key-based, key-value-based, right? So you have a key that must be unique. If you write it again, it will just override the value and the value of it. So when you say, give me that, it will say, I don't have it, so it's a cache miss. Then our software goes to the external API, requesting the data, the API gives it back, we store that into the cache layer using the key, because now we have the value. The cache layer will say, hey, I got you. Then the next request you're processing, you're gonna say, give me that key, and the cache will just say, hit, I got you. Simple, right? Not that simple. Because when should we invalidate our cache? How do we know that the external API has new data? We have no idea. That's why caching is, actually caching validation is one of the hard things about computer science, right? So we got Doctrine ORM, we understand that. We understand caching. How can we combine these two things? Doctrine offers essentially 4 different layers of cache. The first one is the metadata cache. Doctrine ORM is a data mapper, which is a specific pattern that we use for databases, that instead of having a class that points directly to the table and knows about that, you have a mapping that says, hey, this class will talk to that table, and the framework needs to figure it out how to map these two and how to organize that. So we in Doctrine, we read the configuration of the class and we put that into a standard format. That's called class metadata. So usually you have annotations, XML. You don't have YML anymore as of the new version that we're writing. So would be nice if you can already start moving on to XML. But this generates the class metadata. And this process consisting figuring out all the associations. Does this class uses inheritance? How can we get every property here? Traits. So we need to think about all the possibilities. And this process takes time. If you're running that over and over again for multiple requests, you're using your CPU and memory for not so in a not so wise way. To enable that, you simply say, hey, when you're creating your configuration object in Doctrine, you just say the metadata cache implementation will be that specific. In this case, Redis. Probably you're using a framework to instantiate the entity manager and all the Doctrine components. And that is read from a configuration, assuming a Symfony bundle or anything. You'll have some way to provide the implementation of all the caching layers. But this is a very nice thing that you can do to speed up, and it's really simple. And you don't need to think necessarily about caching validation here, because considering that every time you release something, the only time that things change is like the class changes is when you deploy a new version. So if you have a cache which is only bound to the version, then to the release, you don't have any problem. Every time you release something is a new environment, and you will have a brand new cache for each deployment. Query, I don't know how you usually use Doctrine to query things in your entities, but essentially you can use DQL, and the query cache works in the layer where it translates a DQL to in an SQL, which is essentially this. This needs to take into consideration what is the platform that you're using to execute the query, because MySQL and Postgres and Oracle, they have different syntax sometimes, and we need to generate the query in the correct way. That layer of cache is or that transformation also happens when you do things like this, when you're using the query builder. So it's also nice to, if you can, to simply configure the query cache, and you have your application running in a much faster way. But you have to understand that when you have queries like this, you will end up with two different cache keys. One that does not consider the if, and the other that does. So you have to understand the implications of using dynamic queries and how much data you will end up in the cache. Next caching layer is about storing the result of a query. This will again use one key for the entire result set of the query. This is really used for this kind of query here, where you're just counting the number of rows you have on a specific table. But you could use for the storing the entire result set with entities, but then you will have to invalidate the result set by yourself. So this is the query. This is how you enable it and how you set it to be used. You just say use result set, result cache, and there is the TTL to invalidate the result set of the query. But there's a better way to handle these kind of things. I don't know if you heard about second level cache. It's like result set cache with steroids that does a lot of things for you. So again, that's this is the structure of the flow of communication in Doctrine. When you enable the second level cache, which is a little bit more complicated because you have to set some configurations about how you're gonna create the regions and which cache you're gonna use and what is the configuration of that, and then you enable it and provide a configuration for the cache. This will add an additional layer there. This additional layer will be able to get all the calls that you have from the unit of work to the database to store data, and it will put in a cache region. And every read operation you will fetch from the cache and not from the database. So it's like it's a transparent thing where you don't know, you don't need to care about when to invalidate things. The second level cache handles that for you. Internally, it has three different regions. One region for entities, the other for collections or associations, and the last for queries. The entity regions will store will use the identifier of the entity and the class name as the name for the key, and the value is the non-hydrated value, so the data that you just fetched from the database. So we will have various entries in your cache server for each entity you got. If you have 1 million entities or objects, you'll have 1 million entries in the entity region for that specific class. The collection stores the result set about associations, but it gets that only it only stores the identifiers. So if you have an association between two classes, you have the data of these objects in the entity region, but the IDs of this specific association in the collection. And the query does the same, but in the level of the query. So you have all the IDs of the entities so that you can fetch, so Doctrine can fetch for you the data from the entity region. Using that is a bit different as well, because now you need to configure your entity to say, hey, this is cacheable, and it will use a specific configuration. The usage of the cache, we have three possibilities: the read-only, non-strict read and write, and read and write. So read-only is it essentially allows you to only store the data in the cache, but you cannot modify. Never. This is really optimal, because Doctrine will not need to know when to invalidate. It doesn't need to track things. It will only say, things are good, it's read-only, you always have that, or you don't have that. That's fairly simple. Non-strict read and write is a little bit more complicated, because as I said, the entire data of the object is stored in the cache entry. This means that if two people are trying to update the object at the same time, this will you have race conditions, so your cache will only be updated by the last operation that you had on the cache. The read and write is something that puts a lock into that specific object or the cache region of that specific object. So when you're trying to update it, it will say nope, someone is already updating, hold a second, or actually it will just throw an exception, and you need to handle that. You can configure that for association as well, which will write to the collection region. And finally, on the query, you just say, hey, this query is cacheable. The key for the cache entry will be calculated based on the query you're sending and the arguments you're providing, right? So this is really important. Otherwise, different arguments which would produce different data sets will be stored in the same place, and that's not good. Okay, so this is how you configure things in Doctrine, and you enable these 4 different layers. The idea is that when you do that, you will be able to handle very like high intense traffic in your application without noticing that much, or without making everything so slow. There is a very important detail here. When you let's say that you're following my advice, and every deployment you're setting a specific namespace for the cache. So you have when you're building your Docker image, or I don't know how you're deploying, but you have a timestamp which calculates the time build, and then that is sent to your dependency injection configuration. I don't know how you manage that, but this is set as namespace of the cache you have. This means that when you switch your traffic to the new service, you have a brand new cache, like it's completely empty. If you have high traffic, there will be consequences. Everyone will try to populate your cache, and then probably your cache server will cry for help. So a good practice around that is to warm up your cache before anything. So before switching off the traffic and saying everything is good, you run a process that will populate your metadata cache, your query cache, if you, or for the most important queries you have. You populate the some data for the second level cache, so that entities that are used by very often will already be cached. Then you will have less hits in your database, less hits in your cache, and your ops team will not try to kill you. Okay, now I'm gonna just talk a bit about things that are the doctrine is working. And I don't know if you saw on GitHub, but we are writing, actually we are rewriting the entire ORM again. I don't know if you if you saw in the past, the Doctrine 2 is a major rewrite of the Doctrine 1, and now we are doing the Doctrine 3 for the ORM at least. And this time we're relying on all the modern things that we have in PHP, because back then we didn't have, for example, OP cache, which means that for the metadata cache we don't necessarily need to have to store data in the cache. We can create a static file, and that static file is OP cached, and it's much faster because you don't have to connect to an external thing to retrieve data. Everything is already there. You just file system, and the OP cache will resolve that. Things like the second level cache, the read and write usage. Unfortunately, we didn't manage to put it in the Doctrine 2 before of the lock that we've made there. But the only way we lock the entity region is through a file system, which means that if you have a distributed environment, you'll be writing files in different servers, which is absurd. You won't be able to lock, because if the first request locks here, the second goes here, you won't be able to see the log, so the lock, and therefore you will override your cache and things will not be good for you. So there are great components made by Symfony. I don't know what we will be using, but that's something that we definitely need to improve. There are different things that we are rewriting as well. The annotations library now is already under a different namespace for the development of the version 2. We're working on the new migration things. The Doctrine cache will probably get updated as well. So this was my talk. I hope that this helped you to at least to clarify a bit that Doctrine ORM is not that a monster, but it is tricky, and you can really benefit from all the caching layers and use them properly. Thank you.